So question 7, we want to solve this equation by factoring. Right now, it looks kind of linear. But notice how it has fractions. So remember, if the variable is in the denominator, we have to exclude what makes the denominator equal to 0. So the only thing that's on the denominator is x. So if we set x equal to 0, that's what we have to exclude is 0. So if we solve this equation and get 0 as an answer, we have to throw that out. So as we move forward in solving this, one of the things in equations is we don't want fractions. So when I have this 10x minus this 21 equals 10 over x, what we want to do is multiply by the least common multiple of the denominator. In other words, the only denominator we have is x. So what we want to do is we want to multiply each side by x. So we're going to multiply this side by an x, and we're going to multiply this side by an x. So on the left side, the 10x minus 21, we're going to multiply it by x. And on this side, we're going to be multiplying the 10 over x by x. So on the left side, notice how x times 10x is going to be 10x squared. X times negative 21 is going to be minus 21x. Over here on the other side, notice that the x's are actually going to divide out and give me just a 10. So this actually turns into a quadratic equation. So a quadratic equation, we want to set equal to 0. So this 10 is going to move to the other side, which means it's going to change sign. That's like subtracting 10 on both sides. So 10x squared minus this 21x is going to be subtracting 10, and that's now going to equal this 0. So now we have to factor this. To factor it, we pick up on that this is not a perfect square because there's nothing squared that gives me a 10. And there's not a common factor because this 21 kind of messes that up. So since we can't get rid of this coefficient of 10, we're going to use the box method as a way to factor this. So in the box method, the quadratic term, which is the 10x squared, goes in the top left. The constant, which is the negative 10, goes in the bottom right. Now the catch is, though, since there's this leading coefficient, we have to multiply the leading coefficient to the constant when we create big T. So 10 times 10 is going to be this negative 100. So we're going to have this negative 100, and we're going to have to try to find the factors of negative 100 that give me a negative 21. So again, if we need to use our calculator, we can type into the calculator y equals this 100 over x, and it'll give me a list of factors for 100. So if we get y equals, if we clear this off and type 100 divided by x, and then go to my table. So 1 times 100 would be a factor pair. 2 times 50. 4 times 25. That looks pretty good, that 25 and 4. 5 times 20. 6, no, 7, no, 8, no. 10 times 10. So notice that the 10s are repeating at that point. But back to that 25 and 4, notice that to get a negative 100, one of them's got to be negative. But to get this negative 21, the bigger number is going to have to be negative. So what we're picking up on is this has got to be a negative 25. So what we can do then is put these numbers in these two spots. So I'm going to go ahead and put the 4x here and the negative 25x here. That's going to be my linear term. So the 10x squared represents my quadratic term. My linear term gets broken into two pieces, and then we have this minus 10, and that completes our 4 squared. Now, the GCF between a 10x squared and a 4x, notice how they both have a 2 in common, and they have an x in common. So 2x becomes the GCF. So then I go up here and ask myself, well, what times 2x gives me 10x squared? That's got to be a 5x. 5x times 2x is 10x squared. What times 2x is 4x? That's got to be a 2. 2 times 2x is 4x. What times 5x is negative 25x? Well, that had to be a 5. 5 times 5x is negative 25x. And does 5 times... Nope, that's got to be a negative, doesn't it? So -5 times 5x is -25x. Does -5 times 2 give me -10? Yeah. So what this tells me then is this 10x squared, let me go back to the other color. So this 10x squared minus this 21x minus 10 is equal to 0. That's going to factor into the 2x minus the 5 and the 5x plus the 2. So now that it's factored, we set each factor equal to 0. So we're going to have this 2x minus 5 is equal to 0. And we're going to have this 5x plus 2 is equal to 0. And we're going to solve each one of these linear equations by getting x by itself. So notice how the constant is just going to move to the other side of the equation. That's just going to be 2x equals 5. And then this coefficient is just going to slide underneath and make this x equals 5 over 2, since you're dividing both sides by 2. On this one, you're going to move the 2 over the other side, and it's going to become a -2. 5x equals -2. And then this 5 is going to slide underneath and make this -2/5. So it's going to be my two answers, 5/2 and -2/5. So in my little solution set, I'm going to have this 5/2 and this -2/5 as my two solutions. And again, order does not matter, but you do have to separate them by a comma. And these fractions do have to be, they have to be in fraction form. You can't put decimals in there. And these are reduced. And again, if you were unsure, you could put those into the calculator to reduce them.